yesterday if the recording had any sound due to my broken microphone. I dropped it on the ground. I mean, it just fell like it always falls on the ground. Just like this. So this is my angle, right? So I'm drawing in my little rays here to make an angle. If this is in a circle, the R stands for the radius, right?
Yes.
We're going to call S the arc length, right? The length of the arc of the circle. And this is our angle, and this is a Greek letter. We use this Greek letter a lot in math class. Did we do this yesterday?
No.
You know what this Greek letter is? Theta. Someday you're going to go to college and join a fraternity or a sorority, and all the theta, whatever, alpha, theta, blah, I don't know. I'm not a fraternity sorority person. Theta chi, that's one of them. Sigma chi, that's not theta. Lambda chi, that's one of them. Anyway, some have theta in them. And so maybe you'll be like, oh, I learned that in math class. Now I can go to a party. No, that's not what you should say. But anyway, not what you should say. Theta, all right? So theta looks like this, kind of a circle with a line in it. Greek letter, probably one of the one we use the most in trig class, but there's lots of Greek letters I'm going to teach you about.
Is that like supposed to be O? It's like, don't some Greek letters have like
I don't know. But if we want to relate these values, we can say that theta is equal to S divided by R, or I wrote it out in words for you, the angle in radians. So if you have an angle in degrees, you have to change it to radians first, is equal to the arc length divided by the radius. Usually what happens is they give us the angle and they give us the radius, and they want us to find the arc length. So just do a little math here. If I want to solve this equation for S, what would my equation be here? S equals,
theta over R. Theta times R.
I'm going to say R times theta, but yeah. So these are the exact same equation, just solved for a different letter, right? So at some point when we have a test, you'll need to know that formula. So part of your homework today is just finding arc length. So let's look at a couple examples. Arc length. S equals R times theta. That's your formula. So if I want to find the arc length, they're going to give you an angle. They tell me theta equals 5 pi fourths. And they tell me that the radius of that circle is 20 millimeters. And so then I define what is the arc where that angle intersects the circle, right? And so usually they'll give you a picture. But you're just really going to say that S equals 20 times 5 pi over 4. You can work it out, right? Oh my gosh, it's so much work to say that that is 25 pi. And again, I think 25 pi is a better answer than multiplying it out. Just my opinion. Only maybe 5 years to stick that shit back in. So do number 2 if you haven't already. Anybody else need a calculator? Let's go, Megan. Yeah, we got it already?
No.
12 feet is the radius. That's a big circle. Not really, but kind of. Better than 20 milliliters. Times 7 pi over 4. 21 pi. Yes?
Yeah.
And when we're talking about arc length, we usually just put, like, if you wanted to put units on it, like, you would say the length of that arc is 25 pi millimeters, 21 pi feet. But you don't have to put units on it, but in case you're wondering. All right. The other thing that we want to talk about before we leave section 4.1 is motion in a circle, talking about angular speed and linear speed. Velocity and speed are kind of the same thing. Anybody know the difference between velocity and speed?
Yeah, velocity and speed are different.
Velocity is directional, which means you can have a negative velocity. If you're falling off a cliff, your velocity would be negative because you're falling. Throw it off your duck, positive.
You throw something that way.
Speed's always positive. Speed is the absolute value of velocity, so if you talk about speed, it's always a positive number, but velocity about this? Here's another Greek letter. What letter this is?
Wimbledon.
Omega. We should have a Greek letter quiz. Wouldn't that be exciting? Angular speed or angular velocity, I don't know why we use omega for it. Do you have to use omega? No, you can just say angular speed equals this. But angular speed is the angular displacement per unit of time in a circle. And it is just theta divided by time. I'll put t time here. Your theta, again, has to be in radians, and your time needs to be in whatever unit they ask you to give it in. And so when you read the question, they will tell you what to give the unit of time in. So look at number 3 here. It says, find the angular velocity in radians per second for a wheel making 2/3 of a revolution in 3 minutes. I always feel like that they make this seem much more complicated than it is. You're basically just doing a conversion. You want to take 2/3 of a revolution in 3 minutes, and you want to change that to radians per second. All right? So don't freak out too much about this. Let's write what we have. We know that the wheel is on, that's a really slow moving wheel. It's only going 2/3 of a revolution in 3 minutes. Right? That's what they tell us. We want to make that into radians per second. So let's do the non-trig part first. How many seconds are in a minute? All right, you're just changing. Olivia was changing 3 minutes to seconds all at once. But I'm going to do the conversion and say in 1 minute there are 60 seconds, right? I like to do my crossing out of units. It makes me happy to cross things out. That's why I'm a teacher. I like marking things wrong. I'm just saying. It's So that's the second part. The radian part. How many radians are in one whole revolution? How many radians all the way around a circle?
360.
360 degrees.
So 1 radian. Pi over 80.
I don't know.
Right? If 180 degrees equals 1 pi, right? That's our conversion that we've been using. That means 360 degrees equals 2 pi. 2 pi to go around the circle. So I'm going to say there are 2 pi radians in 1 revolution, because then that will make my revolutions cancel out. Right? So I kind of like angular velocity because I like crossing things out, lining up my units. Oh man, then what happens? So if I just multiply the top, I get 4/3 pi over 180. That would be in radians per second. You think I want you to leave your answer like that?
Yes.
No, we don't leave fractions in a fraction. If I divide by 180, isn't that the same as multiplying by 1 over 180?
Pretty much.
Right? You can simplify that, or you just do it on your calculator. I don't care. Don't leave that. It's gonna be like this. What? Is it ugly? Pi over 135, is that true? Like I... Perfect. 4 goes into 180 45 times. So then 3 times 45 is 135. So that would be pi 1/35 radians per second. And so you just want to make sure that your units end up in the units that they say. So, oh, I got this final number?
Yeah.
I just, like, you could just forget about the pi.
Okay.
You can just take 4/3 divided by 180 on your calculator. Like, I just don't want you to leave a fraction in a fraction. Right? Did you get that?
Yeah.
Okay. And then you have to just keep it as a fraction. And then you just put the pi back with it. Some people think they can't use their fraction button anymore because pi's in here. But you just take the pi out and use your fraction button, and then you can put pi back in it. So don't freak out about the fractions. Okay, so angular velocity, not really that bad. You just do the units that they tell you. You don't even let you know. But then we have something called linear velocity, and I like to try to make you, like, derive this formula. I don't know why I have so many blanks here. I should just give you the formula. But linear velocity or linear speed is the linear distance traveled per unit of time, which makes more sense for people. People aren't really good at thinking about radians traveled per time. So the book says that linear velocity is equal to, arc length over time. That's what S represents, if you remember that first page. And so then I like to remind you, well, arc length is just the radius times theta. So we could substitute here and say R times theta over time. That's the same thing. And then if you really want to be crazy fancy, like, I think this, I think that's a good formula, or R times theta over time. But theta over time is angular velocity, so if you really wanted to change it up here, you could say that linear velocity is R times theta over time, and just separating it, or R times omega. But I think this is the one that I use the most. Theta? Well, you better get used to it. You're going to write theta about 1 million times this semester. Theta? It's just a circle with a line through it. Better than omega, which is just a really curvy W. I don't like omega. How about this one? This is my favorite Greek letter. Mu. 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 There's a shirt you can buy with a cow with a bubble, and it says mu. It just has this symbol. It makes me laugh every time. I don't know. Here we go. This is a really fast Ferris wheel, I think. Calculate the linear velocity in feet per minute of a person on the rim of a Ferris wheel 208 feet in diameter that takes 20 seconds to rotate once. 20 seconds around a Ferris wheel. Doesn't that seem really fast? I don't think so. I threw up on a Ferris wheel once. Well,
Let's just pause for a second. So.
208 feet in diameter. I guess that seems. How big is the Ferris wheel? Is that? It's hard for me to imagine 208 in diameter. You'd think a Ferris wheel wouldn't make you sick, but I rode another ride first that made me really sick, and I told my grandma I wanted to just go sit in the car, and she says, "No, just ride the Ferris wheel. It'll help settle your stomach." So I get on the Ferris wheel, and it's great until that you're coming over the top each time, and there's just this little moment every time that if you're about to throw up anyway, that when you come over the top of the Ferris wheel and you're going around, you're like, oh, not so good. And I was like, I'm gonna throw up.
Like, did you throw up on the, like, off the
and, and so, like, we're waiting to get off the ride. Like, they're unloading each thing, you know? And we're two away from getting off the Ferris wheel, and I just lean forward because it kind of moves. And I just lean forward and just throw up all over the ground. And then I got off the Ferris wheel, and I was like, Grandma, I'm going to the car. And then I threw up behind the slide thing, like you get the little bag, and you go down the slide. I, like, pulled back the thing underneath and just threw it behind it on my way to the car.
How old were you again?
15. 16, like, way too old.
What?
Throwing up
Like
like
9 or 10 or something.
Remember that stupid black thing that looks like a spider that, like, spins around and then it spins? Oh, yeah. I can't, that was too much spinning. Like, that was the moment I realized I was too old to ride those rides. But anyway, that's what this problem reminds me of. 208 feet in diameter, just be really careful. We're not going to plug 208 feet in there, right? If the diameter is 208, what's the radius? 104. Be really careful again, thinking about stuff here. Theta is in radians. If it rotates once, how many radians have I traveled? 2 pi. And then the time. The time is 20 seconds. But they want us to give our answer in feet per minute, right? So 104 feet. So you have two options. One option is just tell me how much of a minute is 20 seconds. 1/3, right? Because 20, 40, 60 seconds. So I could say 1/3 of a minute. Or if you don't think you could do that, you could say 20 seconds, and then you could say in 1 minute there are 60 seconds, and you would end up with 1/3 the same way. So if you need to do the conversion, do the conversion. If you can just change it to 1/3 a minute, change to 1/3. So again, not a terrible problem, except for one, you got to know the formula by the time we have the test. And two, you just got to make sure you plug in the values that they're asking for. Really easy to plug in the diameter, really easy to plug in 20 instead of 1/3 a minute. And so we're going to see what is the linear velocity traveled. 624 pi, is that true? I know, because you're not even really doing it. Some people are doing it, Katie.
No, like we would, like you're the teacher.
I know, but I could type something in wrong just as easily as you. On Monday, I took an AP test while everybody was taking their test, and then I graded it, and I missed 6. And 2 of them, I was just completely stupid. One of them, I had the right answer, like wrote the right answer, and then circled the wrong thing above there.
I do that a lot.
But anyway, I wrote stupid next to it after I graded it. I'm going to multiply by pi just so that you can think about, this is 1,960.4 feet per minute is the distance, the linear velocity. I don't know about you, but that seems a lot. Maybe I'm wrong.
I just feel like it's not a very fast. Maybe we had like a diagram, like a half shape, to kind of keep
Yeah, I don't know.
I think it's one of the very.
Let's go. Next time you see a Ferris wheel, measure it. Like, can you find the diameter for me so we can.
You mean count rotations?
Yeah, have them stop you right in the center, like where the diameter would be, and then just have a tape measure and go along to get to the person to the other side and ask them to hold on to it.
Or you could just stop at the bottom and just do.
Oh, that's much easier.
Circles, you can do this.
16. All right, let's go. So our last example, we can do it. And let's talk about throwing up. We would have been done already. People always complain about this question, so we'll see what you say about it. It says, find the perimeter of a 30-degree slice of an 8-inch radius pizza. So here's my pizza. The radius is 8 inches. We're going to say this is 30 degrees. I don't want the perimeter, circumference. I don't want the whole circle. I just want that little piece of pizza there. So I just want this, right, where this side's going to be rounded. So the perimeter means add up all the sides. Well, I know that the radius is 8 inches. So this would be 8 inches and this would be 8 inches. You with me on that? Seems like a big piece of pizza. How would I find this length? What is that asking for? Arc length. And so to find this, you have to do that arc length, which is r times theta.
Hey, sorry for the interruption, but I do have a couple of quick athletic announcements I want to make. First of all, there'll be no girls middle school basketball open gym tonight. That has been canceled. No girls middle school basketball open gym. Second, their boys middle school basketball game with Eminence tonight has been canceled. There'll be no middle school basketball game tonight and no practice after school. So guys can go ahead and make arrangements to get home after school. No ball game, no practice. Girls middle school basketball also, the open gym has been canceled. Thank you.
So this is like 4 pi thirds. Just throwing out there, unless you multiply pi out and give a decimal, like the exact answer here would be 16 plus 4 pi thirds inches. You don't have to close the end.
I did also 130.
So if you multiply 8 times 31st.
It doesn't matter. It really doesn't.
Yeah.
I was just doing my conversion. Because don't forget that to do arc length, it has to be in radians. If you leave it in degrees, you're going to get the wrong answer. Okay? Look at us. We completed the lesson. I put your homework on there, right? Did I put your homework on there? I didn't.
I guess there's none.
I was sitting here. Look at this. Only 5 problems. Because who is the nicest teacher in the world? This girl.
Mr. Love didn't give us homework at all.
Look. stuff that I just said.
Did I miss it up? I think I got it.